Hello. Algebra students, Mr. Lawrence here, and today we are going to solve systems by a method called substitution. Okay, and substitution is going to be better because it's going to allow us to figure out an exact answer. Remember on problems 3 and 4 yesterday, we had these graphs like this, and I guesstimated my answer to 3 to be 1 and 1/10 for x and 1 and 1/10 for y as to where they cross. But remember, I had no real way of telling if I was accurate. My answer could have been this, 1 and 1500ths and 1 and 900ths. Then again, it might have been this. Okay, I just don't know specifically. We're going to learn how to solve a system by substitution, and we will know the exact answers. So let's get down to it. Now, the first thing you need to do is get one of the variables alone. It doesn't matter if it's x in the first equation, y in the first equation, x in the first equation, or y in the second equation. It doesn't matter which one. Um, it matters only in the sense that you want to solve for the one that's the easiest. And I looked these over, and I think, I'll tell you what, I'm going to solve for y in the first equation. I think it'll be the easiest one to do. Oh, you know what? Now that I look at it, in hindsight, I think it's going to be way easier to solve for x in the second equation. So that's what I'm going to do. After looking over my choices, I think that's going to be the best one. So I'm going to take this second equation and I'm going to work to get x alone. Right? I think this is going to be the easiest one to do. I always want to solve for the one that will be the least amount of work, give me the prettiest answers. It'll make my life simpler. Okay, well, I want to get rid of this 4y, and it's a negative, so I'll add it to both sides. 0 plus 4y is just a plain old 4y. So right now I have 4x, and that's going to equal 4y, right? Okay, now x is still not alone, so I'm going to divide by 4, and I'm going to end up with x equaling y. Okay, and that's kind of a weird situation. That won't happen very often, but it does. It equals y in this case. Now, that I have one of the variables alone. I have x alone, right? Um, I'm going to take the second equation. But wherever I see an x, I'm not going to write x. I'm going to write what x is equal to. This equation right here tells me that x and y are the same number. Therefore, I'm going to take y and I'm going to put it in for x. Usually it'll be a little bit more complicated than this one, but this is just a warm-up problem. So I'm going to write down the equation 2, and I'm going to write plus 3y equals 6. But instead of writing x, I'm going to put y in its place because I know that they're equal. Sometimes it'll say y plus 5. Sometimes it's 2y minus 3. Whatever x is that I solve for, I'm going to put it in y's position. Now, normally I'd have to distribute, but in this case I don't. 2 times y is just 2y plus 3y. That's going to equal 6. All right, I've got some like terms here. 2y and 3y is 5y equals 6. Y is almost alone. I'll divide by 5. And y is going to equal 1 and 1/5. Or better yet, 1 and 2/10. Now you can compare. My guesstimate for y coordinate was 1 and 1/10. It's actually at 1 and 2/10. I'm off by 10%. Depending on what we're doing, that might be a large amount to be off by. So this is way better because it gives me the exact answer. Now you might be wondering how I do x. Well, x is simple. I don't have to go back and do it all again. I'm going to take the equation where x is alone, namely right here, x equals y. And since I know that y is 1 and 2/10, this is the same as y, I'm going to put it in y's place, namely right here. So x is going to equal 1 and 2/10. Coincidence that they're the same. They won't always be the same, but in this problem they are. So you see, these answers would have been totally way off base. But I had no way of knowing that. Now I know that the true solution is that they cross at 1 and 2/10 x coordinate and 1 and 2/10 for the y coordinate. All right, let's see how another problem works. A little bit more involved this time. I'm going to move these equations up a little bit. This is problem number 4 from yesterday. Remember, I had a guess that they crossed at 5 and 7/10 and at 4/10, but I really don't know if that's the case. I'm going to look at all these variables and think of which one would be the easiest to solve for. Well, I'm thinking that 3 would be the worst, or y would be the worst to solve for in the first equation, because 3 is not going to go into 2 and it's not going to go into 10. 6 is going to go into 42, doesn't go into 7 very evenly. I don't want to work with 7/6 if I don't have to. 7 goes into 42, but 7 doesn't go into 6 evenly. I don't want to work with 6/7 if I don't have to. Um, I think by default, 2 is going to be the best, or x is going to be the best one to solve for in the first equation, because 10 goes into 10 is divisible by 2, and 3 can be cut in half relatively easy. I can work with halves not too bad. So I'm going to write down this first equation, 2x minus 3y equals 10, and I'm going to solve it for x. So I'm going to add 3y to both sides. And notice I didn't write it under the 10. I'm so afraid you're going to tell me that 10 plus 3y is 13y. Maddie knows it's not because they're not like terms, right? So I'm going to write 2x, and I'm going to write 3y plus 10. Okay, I like to write my variables first. And now x still isn't alone, so I'm going to divide by 2 all 3 places. And this is probably a situation where I'm going to go decimal, but I don't have to. I could go fraction. And so I'm going to get that x is the same as 1.5 y plus 5. So did you hear how I read that? X is the same as this number here. And if they're the same, one can be interchanged for the other. So now I write down the other equation. I can't write down the 2x minus 3y equals 10. I'm going to write down the other equation, the one I didn't solve for a variable in. But I really shouldn't have written that way. What I really should do is put down the 7, put down, I better give myself a little more room than that, put down a plus 6y equals 42. But here in x's place, I'm going to put a number that I know is the same. What number is the same as x? 1.5y plus 5. I know that they're the same. How do I know that? Well, I solved for x, and I was told, my work told me that x equals 1.5y plus 5. Now I'm going to distribute 7 times this and 7 times that. And so I'm going to end up with 10.5y plus 5 plus 6y, and that's going to equal 42. Okay, so I've got some like terms here. That's going to be 16.5y. And just in the back of my head, I'm thinking 16.5 is going to be 33 over 2. I might want to use 33 over 2. I haven't decided yet. Okay, plus 5 equals 42. Now I'm going to subtract 5. Looks like this answer is going to get pretty ugly here, but that's okay. 16.5y is going to equal 37. All right, well now I've got to get y alone, so I'm going to divide each side by 16.5. And 33 over 2 isn't going to really help me when I do this, so I'm not going to worry about converting it to the improper fraction. I am going to go to a calculator on this one because it's very strange. That's a 16. Hold on a second. Okay, I've got my calculator up and running, and I'm going to do 37, and I'm going to divide it by 16.5. You don't see me use a calculator very much. This is going to be kind of an ugly answer. And there it is. All right, so it looks like my y coordinate is going to end up being 2, and 24 hundredths repeating. Okay, that's a strange answer. We don't get that kind of stuff very much. And if you look back, what did I guesstimate? I guesstimated, oh, my y coordinate isn't even close. What am I doing? I'm making a mistake here. Hold on a second. I see my mistake. I distributed, but I forgot to distribute. Hopefully you caught it. So I'll put my correction in purple so it stands out. Right here, I shouldn't have 5. I should have 35 because I distribute 7 times 5. And so I should be subtracting 35. And when I subtract 35, I should get 7. And I'm going to divide 7 by 16 and a half. And that's going to make a lot more sense than what I was doing. So let me go back to my graphing calculator and I'll do 7. No, I won't. I'll do 7. Uh-oh, we're in spinning wheel of death mode. Okay, I think we got rid of the spinning wheel of death divided by 16 and a half. And there we go. We're going to get 0.42 repeating. Sorry about that, ladies and gentlemen. I got interrupted there briefly, but I think the last thing I said it was 0.42 repeating, right? So 0.42 repeating. Okay, and I'm going to leave that as is. And now I'm probably going to be pulling that graphing calculator up in a second. I'm going to go ahead and solve for x. Now, by the way, I guesstimated to be 4/10 for my y coordinate, so I was pretty close. You know, I was off by 2 pennies if you think about it that way. But the problem is, you know, what if one of you had guesstimated 0.3 repeating or something like that? You just don't know. But this system allows you to find the actual answers. So see this equation here where x is already alone? That's the equation I'm going to use. So I'm going to write x equals 1.5, 1.5, but instead of putting y in, I'm going to put 0.42 repeating, 42 hundredths repeating, plus 5. And again, on this one, I'm just going to go ahead and go to the calculator because these numbers are, you know, long and not very friendly. So let me see here. Let me move my calculator over here. And let me not use that because that'll get me trouble. So I'm going to go 1.5. And to show 0.42 repeating, I could do the fraction 7 divided by 16 fifths, or I could kind of go like this, 42, 42, 42, and do it a bunch of times. And that'll be a pretty close estimation of what it's supposed to be. All right, and then add 5, and there we go. I'm going to get 5 and 63 hundredths repeating. So x is going to end up being 5 and 63 hundredths repeating. Now, if you're honest, you'll admit you'll never have guessed that. And again, my estimation wasn't too bad, but it could have been worse, and I really wouldn't have any way to know if it was worse. So there's the actual place that they cross. So this method is better than just graphing because um, it, uh, it allows us to get a specific answer. All right, now, okay, now we don't have to just have lines intersecting. We can solve a system where one of the equations is quadratic and one is linear, or they're both quadratic or something like that. And so let's do one where we have one quadratic and one linear. And we're actually going to do 2 like that. And these are actually pretty cool. It's the first time I've ever shown these to algebra kids, but with the new standards, they come up. Now, the rules are similar. Like I have to have a variable alone, okay? And I look, notice I have them both equal to y. This is really cool because y is the same as x squared minus 4. So I'm going to substitute this in here. I don't actually have to do the solving step because I already know what y is. Y is the same as x squared minus 4. So I'm going to put this x squared minus 4 in place of this blue y, and that's going to equal the x plus 2. Well, now I have a quadratic equation. And remember, to solve a quadratic, I don't want to get x alone. I want to get it equal to 0. So I'm going to subtract x from both sides, and I'm also going to subtract 2 from both sides. And when I do that, I'm going to get x squared minus x minus 6, and that'll equal 0 because these will cancel. All right. Now, I have to look to factor. The only way you know how to solve a quadratic at this time is to factor. So that's what I'm going to do. I'm going to factor. And I'm going to, think of the factors of 6. I have 1 and 6 and 2 and 3. And I need them to subtract to get negative 1. Well, that's going to be 2 minus 3. So I'm going to rewrite this as x squared plus 2x minus 3x minus 6. That'll equal 0. I'm going to do some GCFing. Remember the GCFing? All right. And so I'm going to get x times the quantity of x plus 2. And I'm going to factor out a GCF of negative 3, and I'll get an x plus 2. It's all equal to 0. And then I'll pull out an x plus 2. Be left with an x minus 3. And I'm going to get two answers for x, aren't I? I'm going to get x is going to equal negative 2, or x is going to, or it's actually going to be an and in this case, isn't it? And x is going to equal positive 3, because this is going to cross in two different places. And I'll tell you what, I'll show you that on the graphing calculator in a minute. Now, since I have two x's, I have to solve for two y's. I think it's going to be easier for me to use the linear equation to solve for y, but you can pick either one. Okay, so I'm going to use the linear version, which is y equal, I forgot it already, was it x plus 2? And so if I put this in for x, I'm going to get y equals 0. So one place they're going to cross is at negative 2, 0. And if I put this in for x, I'm going to get y equal to 5. So they're going to cross at the points 3, 5. All right, let's see how that looks on a graphing calculator. Hold on a second while I get that set up. Okay, I've got my graphing calculator ready to go, and I see I have the two equations in, and I'm going to do a zoom 6, I think, and there it is. Let's make that large. Remember, my answer is negative 2, 0, and 3, 5, and I'm going to hit the trace feature right here, and I'm going to type in one of the numbers, like negative 2. So x equals negative 2, and there is negative 2, 0, and sure enough, it looks like it's on the line, doesn't it? See that little blinking cursor? Now you can see right now I'm on the quadratic. I'm on the equation y equals x squared minus 4. If I hit the up arrow, I'll switch to y equals x plus 2. Now notice I'm a little bit off of this, so I'm going to hit negative 2 here, and if I did it right, I should get 0, and boom, I sure do. Okay, now the other possibility was y is 3, so I'm going to type in 3, hit enter, and when y is 3, or x is 3, y is 5 on the line. Well, let's hit the up arrow or the down arrow, and let's type 3 again. Now I'm on the parabola, the quadratic equation, and look at that, I got 3, 5 again, so I did it right. And we can use the graphing calculators to check. All right, we're going to do one more example, and this again will be a quadratic and a linear. And in this one, the quadratic has y alone, but the linear one doesn't. So I'm going to take this and put it in y's position. Okay, and this is going to be really important here. So I am going to write 2x, right? And then plus 3. Now, instead of writing y, I'm going to write what y is equal to. It's equal to x squared minus 5x plus 6. And then that's going to equal 6. All right. Going to do a little distribution here. Going to distribute here, here, and here. And hopefully I distribute correctly this time. And so I'm going to get a 2x plus a 3x squared minus a 15x plus 18, and that's going to equal 6. All right, now it's quadratic. I think what I'm going to do is kind of reorder things. I'm going to write my exponents in descending order. So my 3x squared is going to come first. Now I have a positive 2x and a minus 15x. I have some like terms. I'm just going to go ahead and put those together. So my plus 2x, my minus 15x, and that'll get me a minus 13x. And I'm going to do one more thing here. I wanted equal, well, I'll just write plus 18 first of all. I won't do too many steps at once. Okay, now I don't want it equaling 6. I want it equaling 0. Oops, I lost my x. And I'm going to subtract 6 from there. Okay, so my simplified equation will be 3x squared minus 13x plus 12, and that'll equal 0. Uh, this is a quadratic. I need to factor it. The lead coefficient isn't 1, so I have to multiply 3 times 12 and get 36. So I'm going to need two factors of 36 that add to get 13. Well, I'm thinking 9 and 4. And I'm thinking that they're both going to be negative. Yeah. So I'm going to have 3x squared minus 9x minus 4x plus 12, and that's going to equal 0. All right. Now I'm going to do a little group in here. I always grab that sign. I think Zach Ingram calls that capturing the sign. And then I'm going to GCF. I'm going to pull out a 3x, and I'll be left with an x minus 3. I'm going to pull out a negative 4, and I'll be left with an x minus 3. And then I'm going to pull out an x minus 3 and have a 3x minus 4. Okay, I'm going to solve for x in both equations. X minus 3 equals 0, so therefore x is going to equal 3. And then 3x minus 4 equals 0. 3x is going to equal 4. X is going to equal 4 thirds, which is the same as 1 and 1/3. All right, so I have my two x values. Again, they're going to intersect twice. And I think I'm going to use the y equals equation. It might be the easiest. So I'm going to have y equals, and what was my equation? X squared minus 5x plus 6. X squared minus 5x plus 6, and I'm going to do 3 first. So when I plug 3 in here, I'm going to get 9 minus 15 plus 6, and I think that's going to be 0, isn't it? Yeah, I think so. So they cross at the point 3, 0. That's one answer. The other point is going to be 1 and 1/3. And on this one, I might go to a calculator on it. And let me get out of this mode so I can quit and clear off all that. And let me see, what's my equation here? It is x squared minus 5x plus 6. So I am going to go 4 thirds. Please don't ask me where the fraction button is. I use the division symbol, and I'm going to square it. There's my square right there. And then I have to do minus 5 times 4 thirds, and then plus 6. So all I did was substitute 4 thirds in x for x. And when I do that, I get 1 and 1/9. That is 1/9. 0.1 repeating is the same as 1/9. So I'm going to have this point and 1 and 1/9. Okay? I could do this 1.3 repeating, and then of course 1.1 repeating. Now when we learn how to graph these, you'll see how that works, but let me go ahead and do it on the graphing calculator. I'll pause the video so you're not watching me type everything in right now. Oh, it's going to be a little bit of pain, but no problem. Okay, so there's my two equations. Typed them in the graphing calculator, and I'm going to hit a zoom 6, and there we go. That's where they're crossing. It's not very pretty. Maybe I can change my window to blow it up, or you know what I'll just do is I'll do a Z box. Hold on. Okay, I'm doing what's called a Z box, and that should cause my equation or my graph to blow up. That looks a little bit better. Now let me hit trace. And one of the values was 3, right? It was crossing at 3, 0. Let's see, I'm on the quadratic right now. X is going to be 3, and look at that, y is 0. Let me shift to the linear equation and type in 3, and sure enough, y is 0. So 3, 0 is a valid solution. Okay, now the other solution, I believe, was like 1.1 repeating. Yeah, 1.3 repeating for x. So let me try that. And I'm going to go, I'm on the linear equation. I'm going to go 1 point, and I'm going to hit enter. And look at that, I got 1.1 repeating. And then I'll switch to the quadratic, and I'll type in 1.3 repeating. I just put a whole bunch of 3's. And sure enough, I get 1.1. So I know my solutions are good. Okay, so we solve the systems by a method called substitution. All right, Mr. Lawrence signing off. Have a good night, everybody.